I'm Mark O'Connell, based at Tatura Smart Farm in Victoria, and today I'll present some experimental findings on project SF17006, which is the experimental stone fruit orchard. And the topic of today will be rootstocks on peach and nectarine. I acknowledge the Summer Fruit Industry Fund, Fruit Hort Innovation. Quick background, we've just heard from Trevor that exports are increasing, particularly Asia, Middle East. We also know in the industry that the quality and the variability in fruit quality does impact our sales and consumer preferences. The industry has a whole diversity of orchard systems and canopy designs, everything from the low density traditional vase type freestanding trees right through to the modern high density two-dimensional trellis type orchards. Orchards are coming into production at the moment. And worldwide, in terms of rootstocks, breeding programs in stone fruit, there's very few of those compared to other tree crops like apple, for example. In Australia, Nemegard's the main industry standard rootstock, and that's particularly pertinent to peach and nectarine. And overall, in Australia, we have limited data on rootstocks in stone fruit. And information on tree survival, the growth and development, etc., the yield, fruit number, fruit size, components, and the fruit quality aspects. So obviously rootstocks and the rootstock selection is a long-term strategy that needs to be decided before crop establishment. The vigor component of a rootstock is a very important for orchard management. It governs tree performance, it governs production potential, yield and fruit quality outcomes. And the main agronomic characteristics as we list there are tree survival and health of the tree, the vigor, the precocity, how early we can get into production, the adaptable to the soils, the climate, and to tolerance and resistance to stress, whether that's water stress, salinity, nematodes, pests and diseases, etc. Overall, rootstocks and systems provide important functions, and they are access to water and nutrients, a barrier to soil stress, and a conduit for signals of plant growth and function. So what we'd expect to see if we have a dwarfing rootstock, what sort of behaviour in the sign, in the top of the part of the tree, the sign? Well, it's decreased growth, and that comes around through decreased crown and canopy size. You see that in trunk size, reduced shoot growth, reduced water shoots. You also get changes in tree architecture, more greater branching angles. You get more shoots that are short and spurs, and we also changes in the flowering and behaviour there as well, with increased flowering and fruit set. So there are currently a number of mechanisms and theories out there that explain this behaviour in reduced tree size due to dwarfing rootstocks. And the 3 or 4 main theories are carbon or nutrient exchange, the hormonal or metabolic signalling theory, or the water relations theory. Worldwide, there is no consensus, not one consensus overall in all the work that's been done around the world on apples and other tree crops as well. Quickly, carbohydrate theory, the nutrition theory suggests that there's a reduced available of carbon and carbohydrates from the root system, and that reserves, it limits what happens in spring, and the main outcome is decreased growth in the tree. The hormone signaling theory, similar sort of story. Everything leads to this reduced growth, but basically ABA and cyanocyanins and gibberellin synthesis are all decreased, root growth's decreased, and that leads to change in tree behaviour, tree size. The water relations theory is, again, another one, whether it's through the graft union or not. There's reduced water uptake and flux, changes in what they call hydraulic conductance, leads to mild water stress, changes at photosynthesis and or reduced tree growth. That's enough on the theory. So our work at Tatura basically is looking at dwarf, semi-dwarf and vigorous rootstocks, and looking at how they impact tree size, how the rootstock affects yield and fruit quality, and the hypothesis is that the reduced growth and changing the production potential. So we've set up 2 carefully designed field experiments, and we're basically keeping everything else constant: water management, nutrition, pest and disease management, soil type, everything else except for the crop that we're growing, that's either peach or nectarine, and the rootstock treatment, which is the genetics. That's an overview of the experimental site at Tatura. And the 2 crops and cultivars are peach and nectarine. The block of peach here and the block of nectarine on a Shep Fine sandy loam, planted in 2013. Vase canopy, 4 litres per canopy, 2 metre tree spacing, 4.5 metre row spacing. And after the 3rd leaf, we have been growing these trees and measuring things for the last 5 years. We've focused on the vegetation and yield and fruit quality parameters. So the focus is looking at these dwarf, semi-dwarf and or vigorous stocks on tree survival, tree growth, tree development, fruit yield and fruit quality. The rootstocks are Nemigard, Cornerstone, Alberta, Crimps 1, Crimps 86 and Catamin. Here's a snapshot of the trees in dormancy this winter. And you can see, as I mentioned earlier, Nemigard's our control, our industry standard, and we can see tree size here and structure, and we can see a lot of suckers occurring on Crimps 1 and also a reduced tree size. So this is what we knew prior to the work. This is the evidence available at the time, back in 2013, 2012, when the study first started. To Nemigard, a very common vigorous rootstock, used in sandy soils. Alberta, typically used in heavier soils. Crimps 86, another new rootstock, considered vigorous, drought tolerant, high pH tolerant, and wet soil potentially tolerant. Catamin, another new rootstock, alternative to GF677, prefers well-drained sandy soils. Cornerstone, another new rootstock, high vigor, disease resistance in nematodes and crown gall. Crimps 1, another new rootstock, cold and drought tolerant and water logging tolerant. So here's a tree size graph schematic and showing from 0 to 100%. And we're comparing, we've got some here that we've captured in our study: Crimps 86, Nemigard, Catamin, and down here, Crimps 1. So that suggests to me that Crimps 1 should be dwarfing. And we should have high vigor in Crimps 86, Nemigard and Catamin. What we don't have information on is the Cornerstone and Alberta. Overall, what are we going to expect? We're going to expect less vegetative growth in a dwarfing rootstock, reduced pruning biomass, that should occur. We'd expect less internal shading, that should lead to improved shoot quality and increased flower bud development. So it's a basic quick snapshot of some of our experimental designs and methods and approaches. And we're looking at phenology, light interception, trunk size, for example, pruning, tree survival and health, yield and fruit quality. And as we're doing today, webinars and presentations. At harvest time, we're measuring fruit number, fruit weight, and internal and external fruit quality parameters. We've got a inline grader here equipped with sensors. We have published on the websites on the HIN throughout the years each experimental treatment, each rootstock, and a time series during the growth cycle each year. So there's a movie here, for example, on the nectarine, and there's one on peach available on the website. So what we've found, well, when we look at tree performance and when we look at fruit behaviour, all the things we've measured, whether that's tree survival, phenology, the pruning weights, tree size, light interception, branch diameter, etc., shoot growth. At harvest, we're measuring leaf nitrogen with the SPAD meter, for example, and suckering. And at harvest time, we're measuring yield, fruit quality. everything we've measured, we're finding significant differences between rootstocks. As an example, last season, 2020-21, in nectarine and in the peach, for the 5 rootstocks under each crop, we are getting differences due to rootstock. So in nectarine, for example, we're getting reduced tree size, less light interception under the dwarfing rootstock Crimps 1. We had no differences in other tree rootstock treatments in the nectarine. Everything was similar to Nemigard in this season. In the most current season, 2021, again, we measured light interception in the late season peach under the 5 different rootstocks. Compared to Nemigard, we can see a slight reduction there in tree size under Crimps 86. What's been happening with pruning biomass over the last 5 winters and summers? So here's the cumulative pruning biomass, that's winter and summer pruning for the first leaf, that's year 3, year 4, year 5, year 6 and year 7 for Rose Bright and for September Sun. And basically, we're not getting much difference in pruning biomass other than the dwarfing rootstock having a large reduced amount of pruning material, being a smaller tree in Crimps 1. When we look at peach, we're comparing Nemigard, Catamount, Cornerstone, Alberta and Crimps 86. Over time, there looks to be a drop off in the Crimps 86 biomass pruning weight over time. In terms of yield, what are we seeing? Well, this is the cumulative yield in fresh weight kilograms per tree in seasons 3, 4, 5, 6 and 7 under nectarine and 3, 4, 5, 6, 7 under peach for each rootstock. And as you can see, there's an order here, and that's the same order we can see in the graph, in the data. And we can see Cornerstone is basically out yielding most rootstocks, especially compared to our industry standard Nemigard, and Crimps 1, obviously being the smaller dwarfing trees, have low yield outcomes. In peach, the late season peach, we got Cornerstone again on the top of the rankings, and a very close second, third sort of ranking for Catamount and Nemigard and Alberta, and then the least yielding crop and rootstock is the Crimps 86 under peach. What's happening to fruit quality and fruit weight and fruit sweetness? So this is a 5-year summary for averages for Rose Bright nectarine. So compared to Nemigard, and fruit weight is in blue, the blue bars. So compared to Nemigard, over a 5-year period, the 5 years of the study so far, fruit size is increased under Cornerstone on the Rose Bright trees. When we look at fruit sweetness compared to Nemigard, their industry standard, we're getting big, significant increases in fruit bricks under Crimps 1, the dwarfing rootstock. What's happening? What's the picture look like for September Sun? We have Nemigard fruit size. There's getting bigger fruit on Alberta, we're getting bigger fruit on Cornerstone, and we're getting bigger fruit on Catamount over a 5-year average. In terms of fruit sweetness, there's not a lot of statistical differences in fruit sweetness among the 5 rootstocks in peach. Another way we're looking at the data is looking at the distributions of all the fruit that we measure across the rootstock treatments. And what we're wondering is whether we can see a shift to the right of the curve. That means we're getting a higher mean value, but the same sort of variation, the same sort of uniform. We might also argue that we might get a more uniform outcome, but at the same mean value, or we get the best of both worlds, where we're shifting the profile of quality and we're getting a higher mean value and more uniform. So here's some data for the first season of Nectarine Rose Bright under the 4 rootstocks in that year. Nemegard is the purple line here, Cornerstone and Crimps 86 do look like there's a shift to the right in fruit size. So there's a huge range in fruit size outcomes here, but the distribution of fruit and the fruit size is suggesting the beginning in that season a shift. When we look at in that same season for Rose Bright on fruit sweetness bricks, we're getting no significant differences between the profiles, the distributions under different rootstocks. Here's a summary from last season. Rose Bright under the 5 rootstocks: Cornerstone, Alberta, Crimps 1, and Crimps 86 in Nemegard. And we can see in fruit number per tree, we're getting the smaller trees, the Crimps 1 trees don't have the capacity to carry large fruit number, hence the yields are low, fruit numbers low. However, their fruit weights in this season was maintained very similar or statistically similar to the Nemegard. However, they were sweeter fruit, but more firmer fruits are less mature, but they had higher percentage red skin colour. So they were sweeter fruit, more red fruit, but not as the yields were down. So in summary, what have we found for tree growth metrics? We found in the Nectarine, the Crimps 1 showed dwarfing traits. We saw that in reduced tree size and vegetative growth, whether that was everything from pruning biomass, main branch size, light interception, shoot length. We did see excessive levels of suckers under Crimps 1, and we continue to see that. We did have some suckering on Crimps 86 as well. It was greater than the standard Nemegard. Crimps 86 also showed some semi-dwarfing traits in the light interception data across many years. Alberta and Cornerstone had similar growth and development compared to Nemegard. We've got a summary here for peach, where tree survival in the establishment years was slowest under Crimps 86 and Catamount. Crimps 86 did show semi-dwarfing traits. There was some suckering in Crimps 86. The other 3, Alberta, Cornerstone and Catamount, had similar tree growth and development. In terms of yield and fruit quality, the main messages are Cornerstone increased average fruit weight and skin colour compared to Nemegard. Crimps 1 produced low yields, good fruit size and sweetness, and improved colour. Yield and quality under Alberta, Crimps 86 were similar to Nemegard. For peach, Cornerstone and Alberta increased fruit weight and red skin coverage. Crimps 86 produced similar yield, fruit weight and bricks, however did have increased red skin coverage. Yield and quality under Catamount was similar to Nemegard. As I've covered that off earlier, so the main conclusions is that we examined our peach and nectarines using dwarf, semi-dwarf and high vigour stocks and found that we did induce vigour effects on tree growth, tree development, yield and fruit quality. In summary, Cornerstone, high vigour, large sweet fruit and high yield. In summary, Crimps 86, semi-dwarfing, and Crimps 1, low yield, dwarfing and excessive suckering. Further information, we can refer you to the latest issue of the Australian Tree Crop Magazine, also posted on the HIN. We've developed production protocols and grower information. They're on the HIN. We've got published scientific literature and summary tables of yield and quality for each experiment on the HIN. You can contact me directly or ResearchGate, and I acknowledge the funding body and the project team members.